So right off the bat, let's use our definition of derivative. So let's use the one with h. Limit as h approaches 0, we're going to have fx plus h minus fx divided by h. This is our definition of derivative, right? And so using this model, well, what is the next step, right? The next step would be to find the fx so we can do this. So what is fx? Well, fx in this case, you can see here, well, we only have a natural log, right? I don't see any other function. So let's try with natural log. So we have fx natural log x, right, like there, right? And so the f prime of x would be actually a natural log x plus h minus our natural log x divided by h. Okay, now I'm going to move this over a little bit so I can make some space for the limit. Take the limit as the h approaches 0. Okay, and so we have this formula here, which kind of start to look like this, but look at the inside. We have 1 here. So 1 plus x, and we know that x is a variable. So we don't need to sub anything but 1. So let's try, let's try to sub our x as 1, okay? So when f prime 1, which is x equals to 1, we have a limit, again, as h approaches 0, we're going to have natural log of 1 plus h minus natural log of 1 divided by h. And to kind of understand what we have here, well, let's take a look at this one. Natural log 1. What does natural log 1 means? So the output of the natural log function gives you the power to which e needs to take in order to get this value. Okay, so for example, you can see here natural log 1 is asking, okay, what power does e needs to, right, which is our output of the function, in order to get a value of 1. Well, the answer to this question is 0, right? E to the power of 0 is 1. So natural log 1 basically asking what is the power that e has to raise to in order to get 1, and the answer would be 0. And so what we can know here, okay, this entire thing is actually going to equal to 0. And minus 0, we don't really need to put anything there. So what we're going to get eventually is actually natural log 1 plus h divided by h, limit as h approach 0. Okay, so we have this equation here, and having this equation is not enough, because if we look at the question, it looks a little bit different, right? We have the same structure, we have the same everything, but as you can see here, it has x, it has x, but here we use h, and h. So the question is, how do we solve this? Well, we don't really need to solve anything. Basically, we know that h is actually a dummy variable. The reason we call it a dummy variable because we can just switch it, right? We can switch it to x, y, z, a, b, c, d, doesn't matter. As long as we just simply switching the variable or calling it a different name, right? So we have limit as x approach 0, natural log 1 plus x divided by x. So now we have the same value as upstairs. So now we have the same equation, right, as the above. And now you might be thinking, so okay, so we proved that f prime 1 is basically this one. So how does that allow us to prove that it equals to 1? Well, as we know that, okay, now we confirm that actually natural log x is our, correct fx. So we can just start differentiating. So our f prime x is equals to, right, our 1 over x. Because you differentiate natural log x, what you're going to get is 1 over x. And so now we input f prime 1, which is the same thing as here, right? So what we're going to get here, so 1 over x, we input 1 is 1 over 1, is going to equals to 1. So f prime 1 is equals to both this one and also equals to 1. So we really have just proved what we're looking for. So f prime 1 is equals to as limit as x approaches 0, natural log 1 plus x divided by x, and then which is also equals to 1. Okay, so I hope this makes sense to you. It's a super simple and fun exercise, but really it really teaches you the fundamentals of derivatives, right? The way you kind of have some fun with it. So I hope you enjoyed this video and stay tuned for more. Thank you so much. Please like and subscribe, and maybe leave a comment as well.